Swayam Prabha. Digital India. Educated India.
Hello and welcome back everyone. We are learning the basics of building construction. Today we are going to learn about painting. In the last module, we had learnt about pointing and plastering. Today we are going to discover paints and painting. Let's first talk about paints and its composition. Paints are liquid compositions of pigment and binders which when applied to the surface in thin dry coats form a solid film that imparts a decorative finish. Other than imparting a decorative finish, it also gives protection to the base material from weathering, corrosion and other chemical and biological threats like vermins. So basically we are dealing with liquid compositions of pigments and binders. So that gives us an indication that pigments and binders are some of the elements that we are going to use in creating paints. We will of course learn in detail what are the other things that we need to add to create paints. The common types of protective or decorative coatings that we generally apply in buildings include oil paint. These are drying oil vehicles or binders mixed with an opaque and extender pigment. Water paints are pigments plus vehicles which are based on water, casein, protein, oil emulsions and rubber or resin latexes separately or may be used even in a composition or a combination. Calcimine are water and glue with or without casein plus powdered calcium carbonate and any desired color pigment that we require. Varnish is a transparent combination of drying oil and natural or synthetic resins. Enamel is another type which is a mixture of varnish vehicle plus pigment. Lacquer on the other hand is a synthetic resin film former, usually nitrocellulose plus plasticizer, volatile solvents and other resins are used. Shellac is a type of resin which is secreted by the lac insect and that is dissolved in alcohol to create this type of protective or decorative coating. Aluminium paints are fine metallic aluminium flakes suspended in drying oil plus resin or in nitrocellulose. So these were some of the common types of decorative finishes that we use in our buildings. When we are selecting a particular material for paint, it has certain ideal characteristics that we are targeting. First of all, the paint should form a hard, durable surface. This is what our surface is going to be exposed to, weathering conditions. So we want it to be hard and durable. It should be very attractive in appearance because that is the final look that our facade will have. It should also be cheap and readily available. It should be easy to apply on surfaces, especially if we are dealing with surfaces of different textures. We can of course create different finishes in our plastering. We've already learned that in our last module. So the paint should have the characteristic that we can easily apply it on different surfaces. It should have a good spreading capacity. So it should easily spread over a large area on the surface, failing which we will actually end up spending too much paint. So if a material or a color doesn't spread easily over a long area in long strokes, we end up using more and more buckets of paint. So that's not something we want to do because it will become uneconomical for us. So the spreading capacity, if higher, that makes the paint much more economical and it also makes the application process smoother for us. It should dry in reasonable time. We do not want to be staring at the walls for ages, waiting for the paint to dry. It should not show hairline cracks after drying. The color imparted should be uniform. Of course, we don't want different patches of various types of colors and shades throughout our wall. We want a uniform finish. So the paint should have that characteristic that it uniformly spreads the pigment throughout the surface of the wall. It should be stable over a longer period. So when exposed to atmospheric agents, it shouldn't be easily affected. It shouldn't change color. It shouldn't undergo different deterioration throughout time. It should last for a long time. So that is again going back to the first point, it should be a durable surface. Now let's take a look at what are the constituents of a paint. Paint is generally made up of 5 constituents. The first one is called a base. The second is a vehicle or a carrier. The third element is called a dryer. Then comes a coloring pigment. And last constituent is a solvent or a thinner. So base, vehicle or carrier, dryer, coloring agent and solvent or thinner. These are the 5 constituents that we need to mix to create an ideal paint. Now let's see what each of these constituents mean and what characteristics they should have. First one was called bases, right? So it is the principal constituent of any paint. This is the part which possesses all the binding properties and it forms an opaque coating. So this is what is going to help us hide the surface in the background. Commonly used bases for paints include white lead, red lead, zinc oxide, iron oxide, titanium white, aluminium powder and lithophone. A lead paint is suitable for painting iron and steel works as it sticks to them well. However, it is affected by atmospheric action, so it will be deteriorating over time and it should not be kept as the final coat. Zinc, it forms a very good base, but it is quite expensive. Lithophone, which is a mixture of zinc sulfate and barytes, is cheap. It also gives a good appearance, but it is affected by daylight. So we do not want to use it in the exterior walls. Lithophone as a base is only applicable if you are dealing with interior work surfaces. So if we have an interior wall that we need to paint, go for this type of paint. It will be affordable and it will also give a good appearance. Now this is exactly why when we are purchasing paint in the market for even painting our own residences, we have different types of paints coats which are applicable in interior walls, and we buy different kinds of paints when we are doing exterior painting. So this is exactly where the difference comes in, because the constituents of interior paints and exterior paints is completely different starting from the base itself. The next constituent is called a vehicle. Now the vehicles are the liquid substances which hold the ingredients of the paint in liquid suspension. We're adding a lot of things to the mix, so we need something to carry these in a suspended form. This allows the paint to be easily applied to the different surfaces. So the workability of the paint, the fact that we can have good spreading capacity, that will depend upon the vehicle. Now there are various types of materials that we can use as vehicles. So we are going to discuss 6 of those types. These are the commonly used ones. The first one is called natural drying oils. Now these drying oils gets hard by absorbing oxygen. The natural oil that was used for many years as a standard paint vehicle was linseed oil from flax seeds. It's a very common oil that we've been using for years to create paints. It's a very naturally occurring vehicle. Nowadays, following oils are commonly available in the market. Tung oil, this is for faster drying. It has good compatibility with varnishes as well. Oiticica oil is similar to tung oil. Safflower oil is used as a non-yellowing oil. So this doesn't become yellow over time. The soybean oil is used for flexible films, and the dehydrated castor is used for when we need good adhesion and we need fast drying. So tung oil and dehydrated castor are two vehicles we can use which undergo faster drying. Fish oil is commonly used in low cost constructions because it is considered to be inferior to the other constituents that we had just discussed. Alkyds are a very widely used paint vehicle. They are synthetic resins that are mixed with various vegetable oils to produce clear resins. Now this modification of using vegetable oils makes them harder than natural oils, which was the previous example. The relative proportions of oil and resin determines the properties of the film. So depending upon where we want to apply it, how we want the workability and consistency to be, we can actually alter the proportion in which we are mixing oil and resin. The film is usually air dried and heat hardened. Latexes are based on emulsions of various polymers. This includes acrylics, polyvinyl acetate, styrene butadiene, polyvinyl chloride, and even rubber. The benefits of using latexes as paint vehicle include easy application, quick drying, absence of solvent odor. It's very easy to clean after applying, so the application tools can just be cleaned using simply soap and water. The film adheres well to various surfaces. It has a very good color retention property as well, and it comes in varying degrees of flexibility. So it makes it applicable to various types of surfaces and situations. The fourth type is epoxy and epoxy polyester. Now, epoxy coatings are formed by adding a catalyst to the liquid epoxy right before application. Films are equally hard as many baked on coatings and are resistant to solvents. But oil-based epoxy esters harden on oxidation without the need of any catalyst. Now, compared to the catalyzed epoxies, they are less hard and they are chemically resistant but are fast drying and easy to apply. Now, to make paints usable for interior surfaces and increase their chemical resistance, epoxy polyesters are mixed just before use to produce a smooth surface. Polyurethanes, these are produced especially abrasion treatment fast hardening coats. So two component formulations, they have various types of pot life and they are mixed just before use. So one component formulations are cured by evaporation and reaction with the moisture in the air. So 30 to 90% relative humidity. So the evaporation and the reaction with this water vapor in the air is going to be the element which is going to cure the one component formulations, and oils and alkyds are also added to this particular type of vehicle. The sixth one is the vinyl solutions, and these are solutions of polyvinyl chloride and vinyl esters, and they dry very rapidly. They are sprayed as thin coatings to enable successive build up, and they are usually having very low gloss, high flexibility and inertness to water. They are highly weather resistant also, and they are sensitive to some solvents, and adhesion in this case of vehicle is slightly less. The next constituent of paint, we are just done with vehicles. We are now moving on to thinners, which is the next constituent of paint. Now, thinners are used to increase the spreading qualities of paint by reducing the viscosity volatile constituents, and this is also known as a solvent. They should not, of course, react with other constituents. So, we want to use chemicals which do not react with the bases or the vehicles. And after paint is applied, thinner evaporates and the paint dries. So, this essentially is not left behind. Most commonly used thinners are turpentine, and mineral spirits, which are derivatives of petroleum and coal tar. Different types of thinners are used for different types of paints. So let's take a look. If we are dealing with oil paints, then the type of thinner we want to go for is either spirit of turpentine, naphtha or benzene. If we are going for spirit liquors, we want to use alcohol as a thinner. For cellulose paints, methyl amyl acetate is a good thinner choice. For distempers, we will of course learn distempering in detail today. So distempers use water as a thinner. The next constituent of paint is called dryer. Now these are catalysts which are used to hasten the hardening of drying oils. The function of a dryer is to absorb oxygen from the air, supply that oxygen to the vehicle for hardening. Now these are salts of heavy metals, especially cobalt, manganese and even lead, to which certain salts of zinc and calcium may also be added. Iron salts are also used. Generally we use it in dark coatings and they harden at high temperatures. Now caution must be taken to avoid rapid deterioration of the oil by over-oxidation. So you do not want a catalyst which speeds up the process so much that it will cause damage to the oil by over-oxidation. So the excess of dryer is very harmful because it destroys the elasticity and eventually it causes flaking in the finished paint coating that we see. The next constituent of paint is the main part, the pigment, that is the color. Now the pigments are used to give the required color to the paints. These are fine particles and have a reinforcing effect on the thin film of the paint. They may be classified as white and colored or as opaque and extender. So extender are transparent organic binder films. They are not essentially imparting an opaque color to the film. The power of the pigment depends on the difference in index of refraction of the pigment and the surrounding medium. So in case of opaque pigments, these indexes have significant difference from those of the surrounding mediums. In case of extender pigments, the indexes are nearly the same, which is exactly why they are providing a transparent organic film. They are not essentially altering the opacity or the color to a great extent. Now using a single or a combination of the following pigments, we can get the desired tint. So we can go for each of these colors in individual format, or we can of course go for a combination of 2 or 3 of these to arrive at the color which is desired for our surface. Sometimes even during painting on site, our workmen are going to mix different pigments to arrive at the color that is desired for the surface. Oftentimes white is mixed with an existing color to lighten it and give it a much more subtle look as well. That is done on site. So if we are using red, we can go for Indian red, Venetian red, vermilion red, carmine or even red lead. So that's different versions of red. Many other versions are available, and of course we can create more versions by mixing it with other pigments. Black can be lamp black, carbon black, bone black, graphite, vegetable black and ivory black. We can also go for browns like burnt umber, raw umber, burnt sienna and the Van Dyke brown. Green includes Paris green, chrome green, green earth, verdigris copper sulfate. For blues, we can have the popular indigo, Prussian blue, cobalt blue or the ultramarine. Yellows, another popular color choice, could be chrome yellow, raw sienna, yellow ochre or zinc chrome. So we can create many versions of colors using these. The concentration of pigment in a paint is denoted by something called the pigment volume concentration number, or the PVCN. Now, how do we calculate the PVCN? The formula for it is V1 divided by V1 plus V2, where V1 is the volume of pigment in the paint and V2 is the volume of the non-volatile vehicle or carrier in the paint. So, we are basically creating a ratio between the pigment portion of the paint to the combination of the pigment portion and the non-volatile vehicle. That will give us the PVCN, or the pigment volume concentration number. Now, the durability and the gloss of a paint is inversely proportional to the value of the PVCN. Please note that the durability and gloss of a paint is inversely proportional to the value of its PVCN, or pigment volume concentration number. Now, different types of paints, depending upon what we are painting on, the surface that is the background, we will choose a particular type of PVCN range. So, depending upon the surface, the opacity that is required will eventually determine what is the proportion of pigment that we want in our paint. So, if we are dealing with paint as a prime coat on metals, we can go for a PVCN range of 25 to 40. So, the ratio of V1 divided by V1 plus V2 should be around 25 to 40 if we are dealing with metal. If we are using it as a prime coat on timber, 35 to 40 is an expected ratio. For paint of exterior surfaces of buildings, 28 to 40 is sufficient. For a semi-gloss paint, again 35 to 45 PVCN value is suitable. And if we are wanting a faint paint, then the ratio of 50 to 75 would be sufficient. So, again reminding you, inversely proportional. The relationship is such that if you want to go for more gloss, more faint paint, this ratio will be higher. Now, let's take a look at the classification and different types of paints. Here we are going to deal with a lot of terminology, so it's best for you to note them down to keep track. Now, paints can be classified on the basis of binders or on the basis of ultimate usage. So, let's say we are classifying paints on the basis of binders, then we can use terms like oil paints, non-oil resins, cellulose, water-based and other miscellaneous types of paints. Now, if we are classifying on the basis of ultimate usage, they could be for generic purposes, they could be acid and alkali resistant, fire resistant paint, fungicidal paint and other miscellaneous types of paints based on the usage or application. Here are a list of common types of paints. So, we can take a look at all of them in detail, but let's just see this exhaustive list. So, we have aluminium paints, anti-corrosive paints, asbestos paints, bituminous ones, bronze paints, Cassian paints, cellulose paints, cement based paints, colloidal paints, emulsion paints, a very common popular term we've heard, enamel paints, graphite paints, definitely oil paints another popular choice, plastic paints, inodorous paints, silicate paints and synthetic rubber paints. There are of course miscellaneous other types of paints. These are the most commonly occurring ones, and we will see what are the inherent qualities of each of them. Let's start with aluminium paints. This contains finely ground aluminium in spirit or oil varnish. It is visible in darkness also. The surfaces of iron and steel are protected well with this paint. It is widely used for painting gas tanks or water pipes and oil tanks. The second type, that is anti-corrosive paint, it essentially consists of oil, a strong dryer, lead or zinc chrome and finely ground sand. It is cheap, and it resists corrosion well. So it is essentially black in color, but anti-corrosive paints, as the name suggests, is something that can easily deal with corrosion, and it has the intrinsic property to be able to be durable even under stressful exposed conditions. Asbestos paints are used for surfaces which are exposed to acidic gases and steam, and they are also done for patchworks to stop leakage in metal roofs. Bituminous paints are the type of paint which are manufactured by dissolving asphalt or vegetable bitumen oil in petroleum. It is black in color. It is used for painting ironworks underwater. So it has water resistant properties. We know that bitumen is also a very good damp proofing material. So this type of paint can be applied when we are dealing with places exposed to a lot of water. This can especially protect iron and other metal works. Bronze paints are paints which contain nitrocellulose lacquer and bronze as pigments, and they are used for interior and exterior walls both. Casein paints are milk or curd protein, and it is mixed with white base pigments, and this is available in powdered form. It improves the texture and the look of ceilings and walls. Cellulose paints are prepared from nitrogen cotton celluloid sheets, photographic films. Now this is different from oil-based paints as it hardens by evaporation of thinner or solvent. Cement-based paints is also available in powdered form. It consists of white cement, pigment and other additives. This is very durable and it exhibits an excellent decorative appearance. It should be applied on rough surfaces rather than on smooth surfaces, and it's usually applied in 2 coats. The first coat is applied on a wet surface which is free from excess water. We are allowed to dry this surface for 24 hours. Then the second coat is applied, which gives the final finished appearance. Colloidal paints do not contain any inert material due to its colloidal properties. It takes time to settle, during which it actually penetrates into the surface. Oil paints. Now these paints are applied in 3 coats. The first one is called primer, the next is called undercoat, and the final one is called the finishing coat. So oil paints are done in 3 coats: primer, undercoat, finishing coat. The presence of dampness while applying the primer adversely affects the life of the oil paint, so we want to do it on a perfectly dry surface. Now this paint is also very cheap and easy to apply, which is why it is widely used. Emulsion paints contain binding materials such as polyvinyl acetate, synthetic resins, etc. It dries in about 1.5 to 2 hours and it is very easy to apply. This is more durable, and one huge advantage of this type of paint is we can clean it with water. So if there are marks created on the wall over time or it has become dirty, we can clean it with water. Not many of the paint options available in the market will offer this option. For plastered surfaces, first a coat of cement paint should be applied, followed by the final finished surface of emulsion paint. Emulsion paint needs sound surfaces. Enamel paints. Now this contains white lead, oil, petroleum spirit and other resinous material. Now this surface, it resists acids, alkalis and water very well. So if we are dealing with a surface which is exposed to acid or alkalis or even water, we can select enamel paints. Now it is desirable to apply a coat of titanium white before the coat of enamel paint is applied, and this can be used for both internal and external walls. Graphite paints are black in color and they are normally used for painting of iron surfaces. Plastic paints contain plastic as the base. Now these have qualities of quick drying, high covering power and good decorative appearance. Inodorous paints contain white lead or zinc white mixed with methylated spirit. This dries very quickly due to the quick evaporation of the spirit. So spirit is allowing us to ensure that this paint actually dries up pretty fast. Silicate paints are prepared by mixing calcined and finely ground silica with resinous substances. Now silica imparts good adhesive properties and it forms a very hard surface on drying. Synthetic rubber paints are prepared from resins. This also dries very quickly and is little affected by the weather and sunlight. So we can use it on external surfaces as well. Now this resists chemical attack very well too. So this paint can be applied even on fresh concrete. Its cost is moderate and it can be applied easily. But based on the characteristics that it can resist weather elements, sunlight, chemical attacks very well, the fact that we can apply it even on fresh concrete essentially means it's a wonderful choice for exterior paints. So these were some of the common types of paints available in the market that we can use in different contexts. Some are applicable on masonry walls, some on metal. In some cases, we can use it in interior walls. Other paints are more suitable for exterior walls. We can also make a choice from this list based on whether we want a cheap option or whether we can afford something a bit more expensive which is more durable. Other than that, many other factors like the final look of the building that we are going for or the aesthetic appearance, whether or not we have acids or alkalis or extreme exposure to water that the wall will be subjected to. Based on these criteria also, we can select the suitable type of paint. So ultimately, we want to create a surface which is durable and which does not easily show the common types of defects that we are going to take a look at. So it's important for us to select materials which are suitable in different contexts. So let's say if we are dealing with a particular building which is exposed a lot to corrosive gases, we would want to select a paint material which is anti-corrosive. Otherwise, the durability of the painted surface will be significantly reduced. Which is exactly why all of these options that we studied will find application in some or the other location, weather conditions or building based on their usage. The type of paint we select will also be determined by the background or the surface on which we are painting. So just like we had learned in plastering, if we are dealing with stone masonry walls, brick masonry walls, timber or metal lath, we have different number of coats of plaster. Much like that, the type of paint that we are selecting will also be determined by the background material that we were dealing with and the amount of protection that it needs over time. So now let's take a look at the common defects which occur in painting. Blistering is the type of defect which is caused by the formation of bubbles under the film of paint. Now, why are these bubbles formed? They are formed when water vapor is trapped behind the painted surface. That will lead to the formation of bubbles on the final surface, and that's not a look we are going for. Bloom. These are dull patches which are formed on the finished polished surface. This may be due to defects in the paint, or it may also occur if there is bad ventilation in the space that we are painting. Crawling or sagging is a defect which occurs due to the application of paint which is too thick. One will notice that when we are dealing with painting a wall, it is possible that when we have applied the paint, a certain amount of sagging has happened. So there are droplets which are forming, which are crawling down the surface of the wall. That is called crawling or sagging. That usually occurs when the consistency of the paint is too thick. So we need to ensure that we are having the right workability or the right consistency when we are painting a surface. it will also be affected a little bit by the background surface that we are dealing with. Fading is the gradual loss of color of paint, which is due to the effect of sunlight on the pigments of paint. Now, there are certain chemicals which react to sunlight. We have studied that today. So, we know that there are some types of paints, some types of constituents of paints which are not suitable for external application simply because they react with sunlight and undergo changes. So, in those cases, that type of paint should be restricted for application only in interior spaces, whereas we should use more inert materials in the exteriors which are able to resist sunlight or even the other elements of weather. Flaking is the dislocation or loosening of some portion of the painted surface resulting from poor adhesion. So, if the paint is not sticking well to the surface on which it has been applied, there might be dislocation or loosening of some portion. This is also very evident in structures which have been painted a few years back. We can often see that portions or have loosened and come off. This is actually called flaking. Similar to what happens when the plaster comes off. We had studied the common defects of plaster in the previous lecture. So, similar such situations can occur with respect to painting as well. Flashing is the formation of glossy patches on the painted surface. Now, this usually happens because of using cheap paint, bad workmanship or even weather action. So, there will be some parts of the paint when we see the wall at a certain light, at a certain angle, we will be able to see small patches of glossy finish on the surface. Now, imagine having a smooth matte finished paint surface and certain patches of gloss which are reflected in the light. It's not an appearance we want to be going for. That is called flashing and is a very common defect in painting. Grinning is caused when the final coat does not have sufficient opacity and the background is clearly seen. So, let's say we had predicted that a certain number of coats of paints, certain opacity of the constituents of paint is going to ensure that I will have a opaque, attractive final finish. But at the end of the entire process, we see that no, we can still see parts of the background clearly. It is possible that the pigment to non-volatile ratio was something that wasn't sufficient for this type of background finish. So, we might end up seeing some parts of the background. So, it's like, washing down your paint with too much water when we are doing painting, and we can see the different pencil lines behind in the background, right? So, it's a similar situation where we can see the background even after the application of the final coat because it doesn't have enough opacity. So, this is called grinning. Running occurs when the surface to be painted is too smooth. So, the paint in this case flows and keeps few areas from being covered. So, what happens is that if the surface in the background is very smooth and the consistency of the paint is such that it doesn't stay in one place, it flows along the smooth surface. So, what will happen is we will be able to cover certain parts of the wall and the other parts will remain uncovered with the pigment. So, that will give a very haphazard, uneven look to our overall finished surface. That is called running. So, if we are dealing with a paint which is too thick, then we may have sagging, which was a defect we already studied. And if we have a surface which is too smooth or paint which is too runny or too light in consistency, it will flow. So, that will cause running as a defect. So, there has to be an optimized amount of consistency and it has to be carefully selected with due consideration of the background surface. So, based on the surface you are painting on, the smoothness of the surface, the consistency of the paint and the constituents have to be determined. Saponification is another defect in painting which is characterized by the formation of soap patches on the painted surface. Now, this is generally due to a chemical action of alkalis. So, if we are dealing with presence of such constituents, saponification may occur. So, the final painted surface will have some patches of soapy look, which will not give a very even look to the finished surface. So, those were the common defects that occur in painting. So, now let's take a look at distemper. Now, distemper is a water-based paint. And in this case, the binding medium consists essentially of either glue or casein or similar sizing material. Now, the major constituents of distemper are chalk, lime, water, and of course, some coloring agent is added based on the type of pigmentation that we want in our wall. They are also known as cement paint, as this kind of paint can be directly applied on cement walls. So, we do not need to coat the walls with anything else before applying distempers. So, we can also call this type of paint as cement paint. They are a very cheap option and they stay good for about 5 years. So, distempers are used both in interior as well as exterior walls, and generally we apply about 2 coats. Distemper has the following constituents. First of all, we have a base. This would be whiting or chalk. Then we would have a carrier. In case of distemper, the carrier is water. We then have a binder which helps to hold these constituents together. So, we have glue or casein as a binder, and of course, we have a coloring pigment. Water-bound distempers usually come in powder form or paste form, and they are mixed with hot water just before using on site. Now, oil-bound distempers are a type of oil paint, so in which the drying oil is treated to allow mixing with water. So, the difference between a conventional oil paint, which we've already studied, and a distemper is that we are chemically treating the oil paint such that the drying oil can later on site be mixed with water. Glue or casein acts as the emulsifying agent in this case, and they are very much washable. So, as opposed to a water-based, chalk-based distemper, if we are going for an oil-based, oil-bound distemper, we should be able to clean these surfaces later on by washing it. So, that is one added advantage to the other type. Now, distempers are cheaper than oil paints, so we may select this as an option where we require such surfaces, but we don't want to take the expense of selecting an oil paint. They are generally light in color and they provide a very good reflective coating, but they are less durable than oil paints. Of course, we are selecting a more affordable option, so the durability of this paint is compromised in certain aspects. So, first of all, before we begin, we have to prepare the surface. So, the surface to be distempered is first thoroughly rubbed and cleaned. If there is any efflorescence patches which are occurring, it is carefully wiped out using a clean cloth. If there are any surface irregularities, for example, there might be holes or cracks, they are properly filled with putty because we want a complete smooth surface on which we do the painting. The painting is not going to be able to alter the surface at all. It is just going to provide a decorative coating. So, whatever is the background surface texture will be very much visible even after painting. Only the opacity of the pigment is going to alter the color appearance and increase the durability, of course, of the surface. So, we need to use putty wherever there are any form of uneven edges or patches on the surface or background that we are dealing with. The distemper should be kept exposed for 3 to 6 months so that all the moisture evaporates if it is to be done on new surfaces. Now, if distempering is to be done on old surface, then old loose distemper which is already existing should be removed by scraping and then using water. So, this is how we are going to prep the surface on which we are going to then do the next stage, which is providing the priming coat. The priming coat should be applied after cleaning the prepped surface. For ready-made distempers, priming coat as suggested by the manufacturer should be used. So, we need to read the instructions provided. For locally prepared distempers, milk is actually used as a priming coat, where 1 liter of milk covers about 10 square meter of the surface. So, if we know the total surface area of the wall that we have to paint, based on that we can purchase the amount of milk required if we are dealing with locally prepared distempers and we need milk as a priming coat. But of course, if you are dealing with ready-made company provided distempers, they are going to be giving us instructions about their priming coat along with the product. Then comes the coating distemper. So the surface preparation was done, followed by the previous coat, which is the priming coat. Now we are dealing with the coating distemper. Now usually distemper is applied in 2 to 3 coats to ensure the right amount of opacity, to ensure that greening is not happening on our wall. We cannot see the background surface even after applying the final coat. So before applying the next coat, it should be ensured that the previous coat has dried up and it has hardened, and distempering should preferably be done in the dry season to achieve the best results. It will also help us in allowing the previous coat to dry faster before applying the next coat. Now we have to remember that unlike the previous paints, which have very good drying capabilities, the distemper is using water. So if we are applying water in distemper, drying will require a certain amount of time. So if the weather conditions are such that it's not going to dry very soon, it will be problematic for us to finish the work on time. So that was all about distempering. The next type that we are going to study is whitewashing. So we've studied painting, distempering. Now we are moving on to whitewashing. Now whitewashing of surface of buildings can be done for both hygienic and aesthetic reasons. Now whitewash aids in coating and smoothing over rough surfaces, and successive applications of whitewash helps in removing surface debris as well. We'll see why that happens in the prepping process. In order to maintain a clean, neat and uniform finish, it is necessary to adopt proper method for both preparation of the surface and to properly retain the whitewash, and for easy application of the whitewash itself. Now because we are studying whitewash and distemper together, let's see what are the salient differences between both of these. Now distemper is a water-based paint made from glue or resin, whereas whitewash is slaked lime based paint. Distemper provides a more uniform finish and is available in various colors because we are adding pigments to it. Whitewash is primarily white in color, as the name suggests, and can appear uneven. Distemper is less environmentally friendly due to the fact that it has synthetic materials in it, whereas whitewash is far more eco-friendly and it has antimicrobial properties. Distemper is waterproof. Whitewash can be made waterproof by adding lime. It is not inherently waterproof. It has to be made so. Distemper can majorly be used inside houses and buildings. Whitewash can be either used inside the house or outside the house. So the inherent property of both these materials is different. Their application is different. Their sustainability is different. And they also are applied in different parts or surfaces. Let's now take a look at what is the process we follow for whitewashing. First of all, for the preparation of whitewash, we use fat lime. The lime is slaked at the site and is then mixed with about 5 liters of water for 1 kg of unslaked lime. It is then stirred to make a thin cream. So the proportion is, again reminding you, it is mixed with about 5 liters of water for 1 kg of unslaked lime. This mixture should be allowed to have a resting period of at least 24 hours. It is then screened through a coarse cloth to ensure that no debris remain. We do not want an uneven finish. The application of sodium chloride to lime wash helps in the quick carbonation of calcium hydroxide to make the coating hard and resistant. Small quantity of ultramarine blue up to about 3 grams per kg of lime may also be added in the last 2 coats of the whitewash solution. So this will allow us to give the surface a bit more whitish appearance. If we do not use this ultramarine blue, it is possible that we might have a slight yellowish tinge to the finished coat. So for the last 2 coats, to give it a more pristine white look, we want to add a small quantity of ultramarine blue to give it that slight edge of whiteness. Then we have to prepare the surface. So new surfaces should be thoroughly cleaned of all dirt, dust mortar, drops and other foreign matter before applying the whitewash. Old surfaces that have been previously whitewashed or color washed should be broomed to remove all dust and dirt. All loose scales of lime wash and other foreign matter should be removed. For surfaces with heavy scaling, the entire surface should be scraped clean. So once the preparation of the surface is done, we will now apply the whitewash. To apply the whitewash, we use something called the munch. So munch is a type of brush, as you can see in the picture. This is used to apply whitewash onto the prepped surfaces. Usually 3 coats are applied. The first coat should consist of a stroke of brush given from top downwards. So if this is the wall, top downwards is the first coat. The second coat should be from bottom upwards. So the second coat is bottom upwards. The third stroke should be horizontally from right and from another left before it dries. So we are doing sideways for the third coat. So top downwards for the first coat, bottom upwards for the second coat, right left horizontal movement for the third coat. We are doing this because we do not want the brush strokes to be visible in the finished surface. Now each coat should be allowed to dry before the next coat is applied, and whitewashing on the ceiling should be done before we start whitewashing the walls. So we want to prep and finish our ceilings before we touch the walls. Now that was whitewashing. Let's say we are going for color washing. That is, we are adding a coloring pigment to the whitewash. So this is the disadvantage that we had when using whitewashing as opposed to distempering, because distempering gives us the option of using a color pigment. But if we are going for color washing, we can add a color pigment to the whitewash. Similar process, but what we are doing is we are taking a pigment usually of yellow earth, red ochre, blue vitriol, etc., and we are crushing this to a powder before mixing. The color wash is applied in the same manner that we do the whitewashing. For new surfaces, the first primary coat should be of whitewash so that we can create a opaque priming coat on the background surface before we start with the next 2 coats. And for the subsequent coats, we are going to add the color wash to it. So first coat is whitewash, next 2 coats are color wash. So that was all that we had to learn about paints, painting, the process of distempering, the process of whitewashing, and a quick look at color washing in the end. So before we end today's lecture, let's take a quick recap to some of the important things that we learned today. There are 5 chief constituents of paint. The first one is called a base. The next is a carrier or vehicle. Third is a dryer. Fourth is the coloring pigment. And fifth is the thinner. There are many types of paints which are available in the market. We are going to take a look at this again because it was an exhaustive list. So we had aluminium paints, anti-corrosive paints, asbestos paints, bituminous paints, bronze paints, casein paints, cellulose paints, cement-based paints, colloidal paints, emulsion ones, enamel ones, graphite paints, oil paints, plastic paints, inodorous paints, silicate ones, and synthetic rubber paints. Each of these have intrinsic properties that make it applicable to different weather conditions, different parts of the building, and are able to resist different types of exposure like alkali, acids, water, etc. So based on the location and the applicability or usage, we have to select the right kind of paint for our building. The choice will also be dictated by, of course, our affordability. So these are some of the references we can take a look at to further study this in detail. So thank you for tuning in. Today we studied about paints and painting, and we took a look at also distempering and whitewashing in the end. So this was all about the finishing of the buildings. In the previous module, we've talked about plastering and pointing. Today we talked about painting and giving the final look to our facade. So now we are going to gradually move forward to learning about the various types of temporary structures that are required to achieve all the other building components or construction components that we've already studied in the basics of building construction. Hope to see you soon. Thank you so much.